So in our last lecture, we were taking the energy approach to solve the equation of motion. I mean to find the r as a function of theta to know the orbit trajectory. So what is the next step? The next step is there is another equation as I said earlier, which is m. So L is angular momentum, and we know that angular momentum is m r square theta dot. Okay. So now let us do step by step. This part can be written as follows. So you can write r dot square. It's a slight algebraic manipulation here and there. So r dot square becomes 2e by m minus L square divided by mr square, and then we have minus 2 by m v of r. So v of r is what? Just remember, whenever I write v of r, just imagine that there is a minus alpha by 2. So if I write in alpha by r, if I write in terms of alpha by r, it will become plus. Okay, it will simply become plus. Anyways, it's okay. So now what to do? Now you divide this side by this particular term, that is m r square theta dot. So what will be there? So m r square theta dot, and this side you divide by L. L is the angular momentum. So what do you get finally? So you have this okay, just divide the square of it. Okay, just square of it. So divide by square of the second equation. Okay, so what do you get when you do this? You get the following. You get a 1 by r square dr divided by d theta whole square. Now you'd say, from where did we get d theta? Okay, look at it. If you look at this term, then you'll find that there is a term called as the r dot square, and below there will be a term that will be theta dot square. So, because we have divided the term by m r square theta dot square. This term will be what? What is this? This is dr divided by dt, and this is d theta divided by dt and whole square. So dt will get cancelled, and you will be left with dr by d theta. This is how it is. Okay, this step is clear. That can be written equals to 2me divided by L square minus 1 divided by r square minus, see, these are small algebraic manipulation that you can do. So I'm just skipping the step. I'm just writing the results. 2m v of r divided by L square. Agreed? So now this becomes our main equation that we need to tackle, this part. Okay, so what we have done, let me revise. This was the equation of total energy of a planet moving in elliptical orbit. This was the angular momentum of the angular momentum of any rotating object. Then I have divided this by square of this. Then I got this, a little bit of more algebraic manipulation, and I got this equation. So in the next lecture, I will be working with only this equation. Okay, so we are going step by step.